This is the solution for AP Calculus BC 2003, number 3. So we've got this region here, line defined by this, which is an x equals form. Makes me think of dy stuff. We'll see if that's coming. And the curve C given by x equals, it's a piece of a hyperbola. Let S be the shaded region and the line, and they intersect there. So first thing we're supposed to do is, given these two curves, x equals 5/3 y and x equals the square root of 1 plus y squared, we're supposed to find the intersection point, P. So intersection point, I set those equal to each other. 5/3 y equals the square root of 1 plus y squared. And I guess you could do that by hand. You could use your calculator, of course, right? And that would be 25 over 9 y squared is equal to 1 plus y squared. So subtracting that over here, it would give me y, let's see, that's 9 over 9, that would give me 16 over 9, y squared equals 1, so y squared is equal to 9/16, so y is plus or minus 3/4, but I think this is obviously positive, right? It's obviously a positive y value, so y is equal to 3/4, and then since x is equal to 5/3 times that, x would be equal to 5/3 times y, so that would be 5/4. You could do all this with your calculator, but looks like the intersection point P would be equal to 5/4 is the x coordinate, comma 3/4 is the y coordinate. Right? And the next part of part A is, I guess this is another part. Find the value of dx dy for the curve C at point P. Well, let's see. X equals this. And they want dx dy, so that means it's actually set up the right way. So dx dy is equal to 1/2 times 1 plus y squared to the negative 1/2. Times the derivative of what's inside. How come I don't have to multiply by dy dx here? Well, the reason is, here they're asking for dx dy, which means the role of x and y is, those have changed. The variable of choice here is the y, right? It's dx dy. So just when we take dy dx's, x is the variable of choice here, like the right letter, now y is. So that's the derivative, and we want to know at point P what that is equal to. So dx dy at y equals 3/4 is equal to 1/2 times 1 plus y squared. That's 9/16, so that's my 25 over 9, right? The negative 1/2 times 2y, I think I made it through that all right, and that, the negative flips it over, and the square root makes it 3/5, so I've got 1/2 times 3/5 times 6 over 4, or, sorry, how about 3 over 2, it's better, 3 over 2, so that's 9/10, no, 9/20. Just check the rubric and see if that's right. Nope. Yes. No, it's not. What did it do? dx at point P. So Well, I have this all set up right, so let's just see if we can find the error here real quick. This is set up right, and then the y-coordinate is, in fact, 3/4, so that's right. So I have 1/2. 3/4 squared is, is 9/16. So that's 25/16. Whoops, you probably already caught that, didn't you? Plus 1. Of course, this is with calculator, so you can save yourself all this trauma. Okay, so that's going to be, and so when I take the square root of this, it's going to be 4/5, and that's going to give me 12/20, which reduces to 3/5. And they have a cute little shortcut in their scoring rubric. You can check that out if you want. But 3/5 is the right answer. Sorry about that confusement. All right. Part B. Set up and evaluate an integral expression with respect to y that gives the area of the region S. So that region S, with respect to y, it would be this minus this, right? If we're looking at a dy problem from y equals 0 to y equals, what was it, 3/4? So this is a dy problem, right, with respect to y. So that means instead of doing top minus bottom, I'm doing right minus left, and everything is cast in terms of the variable y. So that would be the integral from y equals 0 up to the y value of 3/4, and then the one that's on top is the bit of the hyperbola. That would be the square root of 1 plus y squared, minus the one that's on the bottom, which is 5/3 y, all that dy. That is the integral expression that we're looking for. And they want us to actually evaluate that, I guess. Yep, set up and evaluate. So let's just go ahead and do math 9, fn int, the square root of 1 plus my variable squared minus 5/3 I, and I know that that does not put the x on the bottom of the fraction, right? If I wanted that, I'd have to put parentheses, so that really does mean 5/3 times the variable, in case you're thinking that I don't know how to use my calculator. Comma x, comma 0, comma 3/4, and that should be good. That's approximately equal to 0.347. Good. And part C. The curve C is part of the curve x squared minus y squared equals 1. That's a hyperbola. Show that x squared minus y squared equals 1 can be written as the polar equation. So x squared minus y squared equals 1. We want to turn that into the polar equation. R squared is equal to 1 minus cosine squared theta minus sine squared theta. If you have a longing for your pre-calculus days of doing trig identities, this is about the closest you're going to get to it right here. So let's see if we can turn this into this. So x squared is equal to r squared cosine squared theta, right? Because x is equal to r cosine theta. Y is equal to r sine theta equals 1. Factor out the r squared. Geez, this wasn't very hard, was it? Times. I think you really have to, I mean, you might be tempted not even to write out that step, but you have to humor them, right? Show all your work. That was easy. How many points was that worth? Let's see. Geez, that was worth 2 points. Happy days. Part D. Use the polar equation given in Part C. Well, there you go. That was easy because we need it here too. To set up an integral expression with respect to the polar angle theta that represents the area. Okay, so now we need to think polar here for a minute, right? So I know that my area expression is it's from theta 1 to theta 2, it's 1/2 r squared d theta, right? So I think it's pretty smooth sailing here because I've got the integral, there's my r squared, 1 over cosine squared theta minus sine squared theta d theta. The trick is, what are my angles? So looking at this, I'm going from, like, we've got to think polar now. I'm looking this way, that's clearly angle 0. And then I need this angle, right, up to here. So the question is, what is that angle? So let's see. I know I'm going from 0 to, and then that angle. Well, that angle is the angle created by the line x equals 5/3 y, or in other words, y equals 3/5 x. This is the line y equals 3/5 x. So that means the slope of it is 3/5, which means, like, at any point we have a rise over run of 3/5, right? So what's this angle that it makes? It's the tangent inverse of 3/5. And this is a calculator problem, so you could actually find that angle. If you did that, that's totally fine, and put that angle in there. But that's the tricky thing about this one. And that was worth 2 points, and one of the points was for having these right, including, like, you didn't get anything for just having the 0. So that's a cute little game there. I like it. All right.